Let's go now to the SAT Most Missed Questions. This is my second group. I'm about the sixth one down, and it starts with a chart. And you'll notice here that one of SAT's kind of tricks or things they want to try to do is intimidate you by giving you a chart. Well, when you start to read this story problem with all these words as well, they're hoping people will just skip these. But we start reading, it says there are 5 times as many right-handed female students as there are left-handed female students. So I'm going to go ahead and put my variables in. The left doesn't have very many, so I'm going to call that one my x. And my right I will call 5x, because there's 5 times as many. Then it says, and there are 9 times as many right-handed male students as there are left-handed male students. So again, my left-handed males I'm going to call y, and then my 9 times that for my 9y over here. And what this does is set us up with a system of equations. So going through the left-handed side, I know that x plus y equals 18. And I know then that 5x plus 9y equals 122. So we have a system. You can use substitution, you can use elimination. If we'd gotten further in our notes, maybe you'd be really quick with your matrices by now. But your choice, I think most of you would probably choose to substitute here. I'm going to make x equal 18 minus y for my substitution. So in for x here, I'm going to plug in my 18 minus y. And I go through and do my math. 5 times 18 is 90. 5 times negative y is minus 5y. Again, excuse my handwriting here. That gives me 4y. I subtract that 90 equals 32. Y equals 8. And I don't need to do a full plug-in. The easy way to do this is x equals 18 minus 8. So my x is going to be 10. And it does ask me, my final question is, which of the following is closest to the probability that a right-handed student selected at random is female? So I really only need the right-handed and female. So I plug in my x up here. 5 times 10 is 50. So that's 50 are female out of my 122. And my calculator's handy. I run that through 50 divided by 122, and it matches up with this A. Moving on to question number 2. If you remember, we actually did this problem about a month ago in our journal questions one day. And one thing you know about the SAT is they do give you a formula sheet. Again, my hint to you when you do take the SAT is when you get to the math section and that formula sheet's at the front, tear it out. You are allowed to tear it out. Tear it out, set it on the desk on your side so that you don't have to flip back to it while you're taking the test. And you can use that. And then when you're done taking the math section, you just slide it back in your SAT booklet and turn it in when you turn in your SAT booklet. But you are allowed to tear that out. So when I look at this silo, it can again look intimidating, but really when I look at it, what I have is a cylinder with 2 cones attached. So when I look up my formula for a volume of a cylinder, it's just pi r squared h. And when I look up my volume of a cone, and if you remember this from geometry, it fits exactly 1/3 of our pi r squared h. So this is now a plug and chug to get our answer. The radius on my cylinder is 5, and the height is 10. Some quick mental math, 5 squared is 25 times 10 is 250 pi. I'm actually going to just leave it that way for right now. It's easier to work. For my cone, I again have a radius of 5. And this time I have a height of 5. And 5 squared is 25 times 5 is 125. And I'm going to leave this 125 over 3 pi. Now when I look at this picture, I have the cylinder, which is 250 pi. And I have 2 of those cones that are the exact same size. So 125 over 3 pi plus 125 over 3 pi. If I add my like terms here, ignoring my pi, and I can turn those thirds into decimals because I can see from my answer choices there's nothing exact here. So when I add 250 plus 125 over 3 plus 125 over 3, I get about 333.3 pi. And when I multiply it by pi, it matches D there, which is that 1047.2. So again, don't be intimidated. Just use your formula sheet and go from there. Let's look at question number 3. Here's a parabola, and we're trying to find the best equation that matches this parabola. Now, a couple things you can do. One equation of parabolas is y equals ax squared plus bx plus c. And if you remember, this plus c here is always the y-intercept. So if you remember that much of it, then this point up here at positive 2 will rule out this C right here, because I can't be negative 2. Now, the other two you'd have to FOIL out if you want to use that form. I would rather direct you to the vertex form, which is y equals, if you remember this, a over x minus h squared plus k. And in vertex form, this number in here moves you left or right. And this number out here moves you up or down. And that, when I say left or right or up or down, I'm talking about the vertex itself. Instead of starting at 0, 0, they move. So if it's positive, it moves it up. If it's negative, it moves it down. But remember, anything inside with the x goes opposite what you think. So if it's negative, it's right. And if it's positive, it goes left. So since this parabola looked like if it started at 0, 0, it went up 2, I want this a up here, which went up 2. This one would have gone left 2. And this one down here would have gone right 2. And this one that we already crossed off would have gone down 2. So if you know your vertex form, this could be a 10-second problem because you know which way that equation reads and you go from there. All right, on to question 4 for today. It says in a right triangle, one angle measures x degrees where the sine of x is 4 over 5. So I can draw a quick right triangle here. If I make this my x, sine is opposite over hypotenuse. So the opposite side is 4, the hypotenuse is 5. It asks, what is the cosine of 90 minus x? Well, if you think about 90 minus x, that's the second acute angle. Okay, so if you know that, don't mind my handwriting here, we're talking about this one right here. So I could change that to cosine of y. Well, cosine of y, that's adjacent over hypotenuse, so it's going to be the adjacent side is 4, the hypotenuse is 5. So my answer is 4 over 5. I do want to recall for you, those that are in pre-calc, if you remember cosine of 90 minus x, this is the cofunction. And this is the same thing as the sine of x. So when you know that the cosine of 90 minus x equals the sine of x, if you knew this was 4/5 to begin with, you can just go with 4/5. So once again, if you recognize the cofunction, it'll save you a lot of time. All right, let's look at our 5th problem and final one I'm going to look at today with you. So this says there are B bricks that need to be stacked, and after K of them have been stacked, then in terms of B and K, what percent of the bricks have not yet been stacked? Again, throwing all variables at you, they're trying to scare you and make it so you just give up and choose something. So just to keep this in perspective, I would say start with K out of my B have been stacked. And if I want to turn that into a percentage, I would multiply by 100 to turn it into a percentage. So if I want the unstacked, I would have to subtract B minus K on top. That's the ones that are not stacked over B times 100. And if I think about that one, that's an easy one and it matches B here. The other option for a question like this is to just give yourself some numbers and work at it that way. So it says there are B bricks that need to be stacked and K of them have been stacked. Super nice to make your bricks 100 because then your percentage is right there. Let's say you've stacked 10 of them. Okay, that means that 90 out of the 10 are unstacked, 90, I'm sorry, out of the 100 are unstacked. And then you can sit there and take your K of, so here your B is 100 and your K is 10. And you can go ahead and plug them into A, B, C, and D and figure out which one equals the same percentage of 90 over 100. So kind of multiple options, but don't be scared when they just give you variables. So keep plugging away at these. And I'll give you some more hints on the next group later.